Hi everyone, I'm Shubham. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2021, Paper-1, Mathematics, and the question for this video is this. Alpha, beta, gamma are some real numbers for which this system of linear equations is consistent. Determinant of M is basically determinant of this matrix M. There is a plane P containing all the points alpha, beta, gamma, that means x equal to alpha, y equal to beta, z equal to gamma, for which this above system of linear equations is consistent. And D be the square of the distance of this point from this plane P containing all these points alpha, beta, gamma, for which the system of linear equations is consistent. And we have been asked value of determinant of M and value of D. Now, first of all, P is a plane containing all the points alpha, beta, gamma, for which this system of linear equations is consistent. So that means you can expect a linear equation in alpha, beta, gamma. That would happen in the case of family of planes. And with a bit of observation, if you say, let's say this effectively represents a plane, let's say P1, this represents a plane, let's say P2, this represents a plane, let's say P3, P1 plus P3 minus 2P2 makes the left hand side 0. Check it out. So should happen on the right hand side. So that essentially means alpha plus gamma minus 1 minus 2 beta is supposed to be 0. That essentially means alpha minus 2 beta plus gamma equal to 1. Now this conclusion you could have reached the other way around also by considering the determinant having coefficients of x, y and z as its column. That determinant would turn out to be 0. That means determinant with columns, column 1 being 147, column 2 being 258, column 3 being 369, it would turn out to be 0. That would mean infinitely many solution or no solution. However, we are looking for consistency of the system of linear equations. So that means no solution is not what is acceptable to us. So we'll go for infinitely many solution, for which you'll do d1 equal to 0, d2 equal to 0, d3 equal to 0. And you know what is d1, d2, d3. In d1, instead of column 1 being coefficients of x, it becomes the constant terms. You equate all of them to be 0 and you'll reach in each one of them this linear relationship between alpha, beta, gamma. And also importantly, you should observe that no two of these three planes are parallel. So that means when D, D1, D2, D3, where D, I mean not this D, but the determinant having coefficients of x, y, z as its column, when all these determinants become 0, there will definitely be infinitely many solutions. Why? Because no two plane out of these three planes are parallel. So in that case, the other possibility of no solution would not be there in this case. Now coming to this question 7, value of determinant of M. If you expand determinant of M, that means if you expand determinant of M, you essentially get alpha minus 2 beta, check it out, plus gamma. And that essentially is 1 because alpha minus 2 beta plus gamma equal to 1. Now what about this plane P? So alpha is supposed to be the x coordinate, beta is supposed to be the y coordinate, gamma is supposed to be the z coordinate. So we have x minus 2y plus z equal to 1. And this capital D is supposed to be the square of the distance of this point 0, 1, 0 from this plane P. And that's what we have to answer in question 8. So it's very simple. You put x to be 0, y to be 1, z to be 0, and this 1 you'll take on left hand side as minus 1, divide by, you have under root coefficient of x square plus coefficient of y square plus coefficient of z square. So this essentially becomes 3 by root 6. Now mind it, this is the distance of this point from this plane P. But what we want is a square of the distance. So D essentially will be 9 by 6. 3 square is 9, root 6 square is 6. 9 by 6 is 3 by 2, which is 1.5. And that's the answer for question 8. Thanks for listening. Stay tuned for the next question.